Hi everyone, welcome to the webinar. My name is Olivia. Thank you very much for joining us this morning. Unfortunately, sorry for the delay. Our usual presenters are having a bit of trouble getting in, so I'm just going to start the video for you now.
Welcome to today's tutorial. Let's get started. Let's take a look at the agenda for today. We're going to discuss what a structure is with some examples. We'll discuss built-in structures and their advantages and limitations. We'll have a demonstration and we'll finish with a live Q&A session. So what is a structure? A structure is a feature that's available in our Seascape variable-based logic languages. It's available in variable-based advanced ladder as well as IEC 6.1131. Structures are also called data structures. They are a meaningful group of data that is used as a complex variable type. Each element in the structure, sometimes called a field, is individually named and typed. Let's have a look at an example. Let's say we have an application with a large number of motors that we need to control. Each motor has a common set of parameters of different data types, such as current, voltage, horsepower, RPM, start signals, stop signals, and fault indications. We can use a structure to organize the application. So in this example, we've created a structure and named it motor. Then we added a field name and data type to each motor parameter, which are all currently showcased on screen. Then we created a new variable called main motor, and we assigned it to the motor structure which we just created. Each field within this new variable can be accessed in the application program as its own variable name with its own data type. Dot notation is used to access these. You can also use structures with arrayed variables. So we'll create a variable called pump motor with a dimension of 10 and data type of motor. Now we have pump motor sub 0 through pump motor sub 9. Each field within each instance can be accessed as seen on screen. Now we'll discuss some built-in structures in Seascape. There's a pre-configured structure for 16-bit timers and counters, and 32-bit timers and counters. There's a field for accumulators and a field for flags for both of them. For example, a timer is assigned a variable runTimer, which has been assigned a type of timer counter 16. If you want to access the accumulator, you can access that from run_timer.acc, which is an unsigned integer for a 16-bit timer and a double integer for a 32-bit timer. If you want to access the active bit, then you access run_timer.flags.15. If you want to access the done bit, then you access run_timer.flags.16. We've also got a pre-configured PID structure. Let's say you're using PID instruction to control oven temperature. So you can create one variable and assign it a type of PID. Let's say it's called oven_temp. All the different parameters are accessible with a dot at the end of the variable name. For example, sample period is accessed via oven_temp.sample_period. Now let's discuss some of the advantages of structures. They can reduce programming errors, improve organization, improve readability, and enforce consistency. They are very useful and easy to implement. Now we'll discuss some limitations of structures. Direct memory mapping cannot be done within the variable table. For example, let's say we've got a variable called start_pb for a start push button. The variable itself can be directly mapped to %i5 in the variable window, but main_motor.start cannot be mapped to it. However, a simple ladder run can be created to do this, which we will showcase shortly. Now let's demonstrate structures in Seascape. We're in Seascape with a new variable-based program with nothing pre-configured. We'll create a new structure based on the structure that I talked about earlier. Here are the three structures that are pre-configured by Seascape: PID, timer counter 16, and timer counter 32. We want to add one for our own motor. I'm going to highlight Retain Variables, right-click, and select Add Structure. I need to right-click again, select Rename Structure, and we'll call it Motor. I can also add a comment here with all the parameters associated with the motors. I'll hit OK, so now we've defined the name of the structure. I'll highlight it, right-click, and click Add Variable. We can use the Insert key on our keyboard to add variables. The first one I want to add is current, which is a real variable. I'll hit the Insert key to add the next one. We'll add voltage, which is an unsigned integer. We'll hit the Insert key again. This time we'll add horsepower, which is a real variable. We'll hit the Insert key again, and this time we'll add RPM, which is an unsigned integer. We'll hit the Insert key again, and now we'll add start, which is a boolean. We'll hit the Insert key again, and we'll add stop, which is also a boolean. And finally, we'll hit the Insert key one last time, add fault, which is also a boolean variable. So now we've successfully created a structure called motor. Here are all the different fields within the motor structure, and to take advantage of this structure, we need to create a variable that utilizes it. So I'm going to go up here under Retain Variables, right-click, and select Add Variable. We'll name that Pump Motor. When selecting a data type, we're going to scroll down to our structured data types, and we'll select Motor. So now we've created a variable called pump_motor that has access to all of these different sub-variables. Now we'll build a simple start-stop circuit that utilizes some of the members of this structure. I'll start by adding a normally open contact, which we'll use as our start. If I want to select a structured variable, I can either just type it in, or I can hit the browse button, which I'll do now. So there's pump motor, and I want the start element. Okay, so I've dropped my contact there. Let's right-click and hit New Rung. Now we'll make the stop function with a normally closed contact. I'll type in pump_motor.stop. The next thing I'm going to need is a run contact for this motor. I never created a run contact as part of the structure, so now we'll add that to the structure. I'll go back here, highlight it, and hit the Insert button on my keyboard again. This time I'll type run, so now I've added another element to the motor structure. Now I can utilize that element. I'll insert a normally open coil here, and I'll make it pump_motor.run. Now we can make a sealed contact at the start using this run variable. So we've created a simple start-stop circuit taking advantage of variables that we created as part of a structure. Let's say that this stop button is coming from a real-world input. We cannot use the variable window to directly map it to a real-world input. Let me show you how you would do it for a normal variable. I'm going to right-click under Global Variable and hit Add Variable. We'll name it Stop Push Button and make it a boolean. I'm going to go under the memory location, and I'm going to map it to %i7. That's what we would do with a standard variable, but how do we do that with a structured variable? Well, we'll make a routine which maps all of our real-world inputs to internal variables. Generally, you want this input routine to be one of the first ones that you do, so I'm going to move it up in the logic. Now I've got an input routine. I'm going to add another section to it at the end, and we'll call that outputs, which again is going to allow me to map internal variables to real-world outputs. I want to map the real-world input to pump motor stop, which I'll do in the input section. But before I show you this, let's go back and review how we might map to real-world input 5. At the very beginning of the global variables, which are pre-established in Seascape, we have predefined variable arrays. %i1 corresponds to I sub 0. So if I want to put a contact here that references the real world I/O, that would be I sub 4. Okay, so I'll place that as a normally open contact. I'll start the rung here, and then I will add a coil that will map it to pump motor.stop. This single rung of logic makes the connection between real-world inputs and variables that I'm going to use all over my program for the pump motor stop. So in the output, we'll insert a normally open contact for pump_motor.run. Now we'll go over here, we'll right click and select new rung. That rung is going to be mapped to a real-world output coil, let's say Q1. So %Q1 would correlate to Q sub 0. Alright, so that's the technique that you can use to map real-world I/O into a variable that is arrayed. Now let's program a timer using structured variables. I'm going to time the pump motor run signal, so I'm going to get a contact. I'll use pump_motor.run. Alright, so I'm creating a new rung here. I'll drop a timer next to it, and now it's going to ask for the timer address. Now, I haven't created any kind of variable for the timer yet, so I'll do that now. Let's create a variable called pump_motor_timer. We'll use a 16-bit accumulator, and Seascape is flagging that this is a structured variable that it's looking for. I'll hit the right arrow key here, and now I'll hit the check mark. I'm going to double check to make sure that all of this information is correct. So this is the name I want to give it, and it is of type timer counter 16. Everything else here seems fine. 100 milliseconds is good for the preset. I'm going to set a 5-second set point for the timer. So now I've created a new timer called pump_motor_timer, which is an arrayed variable. If I want to access the accumulator, I'm going to access the .acc element. Okay, that's the accumulator for all of my timers. If I want to access a done bit or an active bit, I can do so. Now we'll show how we might display the accumulator on the screen. We're going to go to the graphics editor in Seascape, and let's start with the accumulator. I'm just going to take a data field object and place it on the screen. Now, when I pick my variable, I'm going to browse for pump motor timer. Okay, now let's select the accumulator for that. 16 bits is good, and we want to display it in tenths of a second. And it's a read-only variable, so we don't need anything under the edit right subheading. We'll go into the legend, which we will make pump timer. Alright, we'll also make the font a little bigger, and we're done. So now we're displaying the accumulator for the pump timer that I just created by accessing the .acc portion of the pump timer. Now let's create a pilot light that will turn on that is tied to the done bit in the timer. So we'll click and drag an indicator out onto our screen, and then we'll select it. This time though, we need to select flags instead of ACC under the variables. Since we've selected flags, there's one extra step. Since it's the done bit that we're interested in, we have to add the specific bit that means done. .15 means the timer is active, and .16 means the timer is done. So pump_motor_timer.flags.16 is what we're after. We'll now go into the legend, and I'll change that text to make it say ready. Okay, now I'll exit out of all of this. So we can access the accumulator here, and we can access the done bit from here. That wraps up our demonstration on structures for today. Thank you for attending today's tutorial. The Q&A session will begin shortly.
Okay, so overview there of using structures with advanced ladder with variables mode in Seascape. Hopefully that was informative. I don't have any questions coming in. So what I'd like to do is just go through the upcoming webinars that we'll be having before Christmas and also into the new year. So we've just seen December the 2nd using the structures with variable-based advanced ladder. So that one's just run. Next week, we've got bootloader updates for OCS. In that, we'll be taking you through a couple of the products that we offer and tell you how to go about. There's a step-by-step guide for how to update the bootloader for those devices. December the 16th, we've got a CAN Open networking webinar. So that will take you through setting up the OCS to work on a CAN Open network, obtaining data from other devices and also sending data out. We don't have one December the 23rd, Christmas week, and we're not having one the first week back, January the 6th. January the 13th, we've got using videos with the owner OCS all-in-one controllers. So that'll be talking about the video object and video hardware and how to feed in video and display it on screen in the OCS. January the 20th, we've got a getting started with IEC part 2. So we did some basic IEC getting started and using each of the languages and simple programs in a part 1 about a month ago. So now we're going to add to that and cover more advanced programming techniques to be used with IEC. And then finally on January the 27th, well not finally, we'll obviously be scheduling more after that, but the last one we have scheduled now is using shift register functions in Seascape. So thank you all very much for your time today, and we hope to see you again on one of these subsequent webinars in the upcoming weeks. Thank you very much, everybody.